So this type of structure is called as star schema. It is called as a star schema. But what we are represented in the previously, that is also in the same format. We are having 4 dimensions, centrally one fact table. Even here also we are representing same thing. Means dimensional model is nothing but again a star schema. But strictly speaking, every dimensional model need not be star schema. But what are the star schema you are defining? That is definitely dimensional model. Every star schema is a dimensional model, but every dimensional model need not be star schema. What does it mean? Means if you apply some special rules on your dimensional model, then it becomes as a star schema. So what is a special rule you should apply? Means for example, you are having a dimension table, a set of dimension tables. And these dimension tables, you are connected in such a one and another, they are communicating. This is not advisable. It is not allowed. A dimension should not communicate with another dimension. If you follow this rule under dimensional modeling, then it is called as star schema. That means if a dimensional model I'll say in a dimensional model, if dimension is not communicating with another dimension, then the structure, then the structure is called as star schema. Then the structure is called as star schema. Or in another way, so you are saying that one dimension is not communicating another dimension. Means if we are communicating, means that is called as normalized. But we are saying it is not communicating. So that means in another way like this, if fact is centrally located and surrounded by set of denormalized dimensions, then the structure is called as star schema. Then it is called as a star schema. So that is the definition of star scheme. The star scheme is nothing but dimensional model. But if you apply some special rule in the dimensional model, that is, a dimension should not communicate with another dimension. If you follow that particular rule, then that structure can be called as star schema. Maybe something like this. I am having some table D underscore customers. This table is consisting something called as a customer ID, customer name, customer type, customer address. I'm having one more table called as D underscore stores. This table is consisting store ID, store name, store type, and store address. Same way I'm having D underscore products. It is also dimension table which is consisting something called as an product ID, product name, product subcategory ID, product subcategory, product category ID, product category. Same way I'm having D underscore times table which is consisting something called as an time ID. I'm having something called as an year, quarter, and month. So these are various tables I'm having. All these are dimension tables. Now among these dimension tables, between these tables, I'm having one table called as F underscore sales. F underscore sales, it is a fact table which should consist only keys and measures. So what are the keys means? Something called as customer ID, product ID, store ID, time ID. After that we are having something called as quantity sold, amount sold. This is my fact table. So this type of structure is called as star schema. Customers is linked to sales table, product table is linked to sales table, stores table is linked to sales table, times table is also communicated to sales table. So this type of structure we are calling as a star schema. It is star schema. Next, snowflake schema. Snowflake schema. What is snowflake schema? So nothing but once again the same structure. That means a dimensional model. So every snowflake schema is a dimensional model. But every dimensional model need not be snowflake schema. So what is the rule you should implement on dimensional model to become as a snowflake schema means? So in the star schema we said that the dimension should not communicate with another dimension. But whereas here that is allowed. A dimension can communicate with another dimension. This is allowed. So if you follow this particular rule, then it is a snowflake schema. In a dimensional model, if any dimension is communicating with another dimension, then the structure is called as snowflake schema. Then it is called as a snowflake schema. So a dimension can communicate with another dimension. But instead of giving like this, we can represent same thing in another way. If fact is centrally located, and surrounded by set of normalized dimensions, then the structure is called as snowflake schema. Now the structure is called as a snowflake schema. So how it looks means, the previous model what you have represented, the same thing I'll represent here in the form of snowflake schema. So I'm trying to take something called as a D underscore customers. It is consisting something called as a customer ID, customer name, customer type, customer address. These are the fields you're having: customer ID, customer name, customer type, and customer address. But instead of writing address directly, what I'm trying to represent here is, I'm saying location ID. I'm taking a field called as a location ID, and I'm having one more table called as D underscore locations. Here I'm having something called as a location ID, region, country, and city. So here locations is a master table, customer is a child table. Both are dimensions, both are maintaining descriptive data, but among these two, locations is a master table, customer is a child table. A set of customers may belong to the same location. Next, I'm having one more table called as a D underscore products, called as product ID, product name. Next, product subcategory ID, product subcategory ID. Next, I'm having one more table, D underscore subcategories. Subcategories. This table is consisting product subcategory ID, product subcategory and product category ID. Another table is there called as a T underscore categories. This table is consisting something called as a product category ID, product category name. These are the various tables you're having. In between these tables, I'm having F underscore sales, which is consisting something called as a customer ID. We are connecting the lowest dimension to the fact table. Customer ID, product ID, maybe same way store ID, maybe time ID. Along with that, quantity sold, amount sold. So these are a set of dimension tables like customers, locations, products, subcategories and categories, and they are communicating with the fact table. This products is having subcategory table. The products for that parent table is subcategories. For the subcategories, the parent table is categories. Categories is having a child table called subcategories. Subcategories is having child table called as products, and the products is communicating with the fact table. Same way, there is a locations table. This is a parent table to the customers. Now by seeing this, don't say that every dimension which is connected to sales to the fact table should have parent dimension. No. If you're having at least one child dimension in the complete structure, that is called as a snowflake. It is not like that all pipelines should have the same number of child dimensions. There is no condition something like that. So to represent that, in the bottom tables I will not take any childs. So here we are having something called as a D underscore stores. This is consisting something called as a store ID, store name, store type, store address. Same way you are having one more table, D underscore times. It is consisting time ID, something called as an year, quarter, and month. So this type of structure is called as a what is this complete structure you're having? This complete structure is called as a snowflake schema. This is called as a snowflake schema. Here fact table is centrally located and connected with normalized dimensions. These two are normalized dimensions. Same way these three are the normalized dimensions. So if you're having any normalized dimensions in the structure, that itself is called as a snowflake schema. So in your dimensional model, it may be in the form of star schema, may be in the form of snowflake schema. But whenever you design your cube in SSAS, the cube will be in the form of star schema only. But what is the model you are using to create a cube? The input model, maybe it is a star, maybe it is a snowflake, maybe it is a relational model. The cube can be designed from relational model, even from dimensional model. So dimensional model means the input objects what you are providing, that may be in the form of star schema, may be in the form of snowflake schema, doesn't matter. But the result what you are creating in a cube, the cube structure is definitely, it will be in the form of star schema model. So what is the third one? Galaxy schema. What is this galaxy schema? As per warehouse principles, warehouse will design in the form of subjects. In the form of subjects. So we will have in the warehouse basically two things. One is an enterprise warehouse, and another is subjects. So whenever you are designing in the form of subjects, those dimensions or those subjects, whether they are communicating only to its own fact table, or is it communicating to another subject fact table, based on that we'll call as galaxy. What does it mean? Means, for example, I'm having a subject, one subject is there with set of tables. It is a dimension object, dimension table. It is also a dimension table. I am representing in the form of star schema, but maybe it is a snowflake schema also. But I am representing in the form of dimension here. That is star schema model I am representing, but need not be. Here we are having something called as in fact. You have designed one particular subject in this format. In the similar way, you are having multiple subjects are available. It is another subject, different subjects you are having. So first one maybe is belonging to something called as in sales, and the second one is belonging to finance. Maybe third one is belonging to marketing. Now in this, all these subjects, for example, I am having one table called as a D underscore items. It is a dimension table which is maintaining the item descriptions. Same table is there even in this finance subject, D underscore items. Even in the marketing also this table is there, D underscore items. So on all these subjects we are having the same dimension table is there. Like this, maybe we are having 30 subjects or 40 subjects are available. So among the 40 subjects, maybe 30 subjects are consisting same dimension table is used called as D underscore items. That means the table is created again and again and is maintaining the data. Now who will design these things? The architect will design it and he will document it. When he releases this documentation to the database team will create these tables. But before giving this documentation to the database team, the architect or the solution provider or modeler should take the approval from the client, then only you should give this document to the database team for creating the tables physically. So whenever you are giving these tables to the client questioned the architect by saying that why you have created this D underscore items table repeatedly. Because of that, unnecessarily space will be wasted. So don't work in this format. Try to work with single items table only. Create the table only in one subject and use it in all the other subjects. Like that, the client has proposed. This is the model given by the architect, but the client is saying that no, don't follow this architecture. Instead of that, you create only one table. Try to create only one table, items table in only one subject area and use it into other subjects. Like that, the client has proposed it. He is saying that remove the items table from other subjects. Keep only in one subject, from other subjects you remove it. So as those subjects also require these items, he is asking to share this table. To this place as well as to the next place. He is asking to use same dimension table into other subjects also. So whenever you design like this type of structure is called as galaxy schema. It is called as a galaxy schema. Instead of creating the dimension in each and every subject area, you are created in one place and you are accessing into other subjects, means then that particular structure is called as galaxy schema. As a definition means, if a common dimension is shared among multiple subjects, if a common dimension is shared among multiple subject areas through fact table, then the structure is called as galaxy schema. That is called as galaxy schema. So this is about dimensional model. Dimensional model is basically again available in three ways: star schema, snowflake schema and galaxy. So when you're working with OLAP system, warehouse system may have star schema, maybe snowflake, maybe galaxy. Sometime all the three things will present. Usually warehouse is designed in the form of enterprise warehouse and subjects. So when you take as an enterprise warehouse, it may be in the form of star or snowflake, but when you say subjects, that subjects may be in the form of star schema, maybe snowflake, maybe galaxy. Possibility is available for all the three. But when you come to the cube system, what you are designing with SSAS, every time that SSAS cube will be in the form of star schema only, which uses dimensional model. But here SSAS cube what you are creating, you are calling this as a multi-dimensional model. Means it is having a facility to retrieve the data in a multi-dimensional format. So multi-dimensional model is nothing but which supports to read the data in multiple perspectives. Multi-dimensional will support you to read the data in multiple perspectives. Means maybe 1 column, 2 columns, 3 columns, 5 columns, n number of columns you can read at a time, and you can display the data and you can analyze the data. So if you are having a facility to read n number of fields at a time, n number of fields in n number of ways, then that process is called as multi-dimensional model. So but internally it is nothing but dimensional model only, but usually dimensional model will support you to read the in two dimensional. So what are the relational models you are having and what are the warehouse model is there? Both will support to read the data in two dimensional, relational model and dimensional model. Both will support to read the data only in 2 dimension, whereas multi-dimensional model will support to read the data with n number of dimensions at a time. Instead of 2 dimensional, 3 dimensional, 4 dimensional, 5 dimensional, and like n dimensional data you can read at a time if it is a cube. But if it is a dimensional model or if it is a relational model, only 2 dimension is possible, x-axis and y-axis. So it is about the dimensional warehouse and what are the models you are having and what is the model you are following under our cube system. So now we should create the cubes. But this is the theoretical information about what is SSAS and what type of architecture it follows internally. So it follows a multi-dimensional model which consists dimensions and facts. Thank you.